Welcome student. Today we will going to discuss the degradation of alkaloid. I am Dr. Devang Pandya from Department of Chemistry, St. Xavier's College, Autonomous, Ahmedabad. The degradation of alkaloid, in which first we will going to see the Hofmann degradation. In this Hofmann degradation, we're going to perform exhaustive methylation method. This method is for the heterocyclic ring opening process. That means how we will cleave the heterocyclic ring and eliminate the nitrogen to give only a simple aliphatic compound. So that is how we're going to perform the degradation for ring opening reaction of heterocyclic compound. We want to eliminate nitrogen to give aliphatic compound. This method is first applied by Wilster in 1817 and further developed by Hofmann, and that's why it is known as Hofmann method. And in this method, to remove the nitrogen from the heterocyclic ring, exhaustive methylation process, one after the other methylation process is carried out. That's why this process is known as Hofmann exhaustive methylation method. It is based on heating quaternary ammonium hydroxide and decomposing it loss or water from hydroxide and hydrogen atom from beta carbon atom. With respect to nitrogen, give olefinic compound. It means that from the nitrogen, very next to nitrogen, beta carbon is there, and if the beta carbon should not have hydroxide or hydrogen from it or hydrogen from it, we will not going to perform this Hofmann exhaustive methylation method. So one of the limitation of Hofmann method that is that the alkaloid containing heterocyclic compound should have a beta carbon adjoining to the nitrogen atom which contain hydrogen atom. So if the beta carbon should not have hydrogen, we cannot perform Hofmann exhaustive methylation method. Now this is the Hofmann degradation method. Already we said that from the heterocyclic compound we need to substitute this nitrogen to get the simple aliphatic compound. For that, what we will do, we are going to perform the reduction in presence of hydrogen and nickel. We are going to get the piperidine, and that piperidine is methylated with the use of methyl iodide. So we're going to get dimethyl piperidine iodide ion, and again we're going to perform the methylation in the basic condition. Dimethyl piperidinium hydroxide is going to be obtained, which is a quaternary ammonium hydroxide salt, and on heating, as already we have mentioned in the earlier case, the beta carbon which lost one hydrogen and the hydroxide from the base will going to remove one water molecule, and ring opening reaction will taken place, and we're going to get delta 4 pentanyl dimethylamine. This pentanyl dimethylamine is further methylated by methyl iodide in presence of silver oxide. We'll again get the quaternary ammonium hydroxide salt, and on heating, again from the beta carbon the hydrogen is released and hydroxide going to form a water molecule is removed, and we're going to disconnect the nitrogen from the heterocyclic ring structure, and that way substitution of nitrogen is taken place in the form of trimethyl azide, and we're going to get the olefinic compound in isomeric form. So that is the total Hofmann degradation process in alkaloid compound which contain a heterocyclic ring structure as a main skeleton in it. Now this again already we have discussed the limitation of Hofmann degradation process. Simple example has been taken for isoquinoline, and on treating this isoquinoline with hydrogen and nickel. So reduction is carried out, dihydroisoquinoline is going to be obtained, and continuous methylation process with the use of 2 mole of methyl iodide in presence of silver hydroxide will going to get the quaternary ammonium hydroxide salt. On heating, we're going to get the ring opening reaction, and again we're going to perform exhaustive methylation with 2 mole of methyl iodide in presence of silver hydroxide. We're not going to get the quaternary hydroxide salt because the beta carbon should not contain the hydrogen in it. As beta carbon should not have the hydrogen, it won't release, and it is not possible to remove the nitrogen from this product by this Hofmann exhaustive methylation process, because this compound do not have beta hydrogen atom with respect to this nitrogen. It does not undergo Hofmann degradation. So here we'll won't get the olefinic kind of compound, as the carbon should not have beta hydrogen in it. That is the limitation of Hofmann exhaustive methylation degradation process. So we have option. If we do not perform the Hofmann exhaustive methylation process, we need to go for MD method. The compound which are not degraded by Hofmann's exhaustive methylation process are successfully degraded by MD method, which consists in reducing an aqueous or alcoholic solution of the quaternary ammonium halide with sodium amalgam in aqueous ethanol. So if we do not have beta hydrogen, as we seen in previous slide for isoquinoline, we can perform MD method by reducing the aqueous alcoholic solution of quaternary ammonium halide with sodium amalgam in aqueous ethanol. This is the MD degradation process. Again, this is not degradable, or we can say obtained Hofmann's degradation of tetrahydrogen isoquinoline. Due to not having beta hydrogen or the absence of beta hydrogen, we cannot remove this nitrogen. Then we need to treat it with sodium amalgam and aqueous ethanol. So we're going to get the trimethyl azide removed from this, and we're going to get O-methylstyrene, and that is how we'll get the olefinic compound with this aromatic counterpart. Again, if we do not have beta hydrogen, and if we want perform the Hofmann exhaustive methylation process, such kind of compound is treated with sodium amalgam in presence of aqueous ethanol. MD degradation process is carried out. We're going to get the ring opening reaction. Gamma dimethyl aminopropyl benzene is going to be obtained, and orthopropyl dimethyl aniline is going to be obtained. So the tetrahydroisoquinoline may also be degraded by direct MD degradation. That means here we have half Hofmann degradation is performed, where the ring opening reaction take place, and then after on the absence of beta hydrogen, we want perform the Hofmann methylation process. So we have treated it with sodium amalgam. Reduction is carried out in aqueous ethanol, and we're going to get the ring opening reaction and substitution of nitrogen atom from the heterocyclic ring structure. Similarly, if we do not need to perform Hofmann degradation, we can directly perform MD degradation as well. Here we have this compound where the first step, reduction and methylation, is already carried out. Then performing reduction with hydrogen platinum, and then after sodium amalgam, we can directly got the ring opening reaction, or either through Hofmann process we're going to get this ring opening reaction, and then treated with sodium amalgam in presence of methyl iodide, we're going to get this O-methylstyrene. And through Hofmann degradation we can get up to this only. So that is how MD degradation can help us to overcome the limitation of Hofmann degradation process. Now another degradation process is first von Braun method for tertiary cyclic amines. The alkaloid containing tertiary nitrogen atom in the ring is treated with cyanogen bromide, that is CNBr. The bromine atom is attached to the carbon atom and the cyano group of group to the nitrogen atom, and thus the heterocyclic ring is going to be cleaved. So this is our heterocyclic ring. We have treated it with cyanobromide. So bromine which remain attached to the carbon atom through this charge, and the cyanide group remain attached to the nitrogen. So cyanobromide is going to be obtained. When this cleavage take place, bromine remain attached to the carbon and cyanide remain attached to the nitrogen. Cyanobromide is going to be obtained, and through hydrolysis we are going to get this ring opening reaction. So this is first von Braun method for tertiary cyclic amine. This is tertiary cyclic amine. For that, the degradation can be carried out by this von Braun method. Von Braun cyanogen method is applied to compound which do not respond to Hofmann method. Where both the methods are applicable, ring opening take place at different point of the ring. We have already reduced the compound, and if we will going to perform Hofmann degradation, we can get the ring opening reaction from here when the cleavage will take place on exhaustive methylation process. But due to the absence of beta hydrogen, further treatment won't taken place over here. If we have this compound and we perform first von Braun method, we can substitute from the either side. That means not from here but from here, not from here but from here we can cleave the compound and we can get this cyanobromide derivative, and then after we can substitute the nitrogen. So that is how first von Braun method is another alternative to overcome the limitation of Hofmann degradation process in alkaloid. Limitation of this von Braun method is that in general fission of unsymmetrical amines by cyanogen bromide give the bromide. The second possibility is the dialkylation of an alkyl group without the ring cleavage. We have cocaine. Cocaine is treated with cyanobromide. The cyanide group remain attached to the nitrogen, but bromine cannot attach to the neighboring carbon atom, and then after treating with HCl and decarboxylation carried out, we are going to get this cyclic structure. So that is the limitation in certain cases. Dialkylation of this N-alkyl group without ring cleavage will taken place and we can't perform the degradation. This is the limitation of cyanogen bromide method, or we can say first von Braun method. Second von Braun method is for the secondary cyclic amine. It involves the treatment of its benzoyl derivative with phosphorus halide. The nitrogen atom is eliminated as benzonitrile with the formation of alpha omega dihalo compound. We have this N-benzyl piperidine. We treat it with phosphorus pentabromide, and we're going to get this intermediate product where dihalo alpha omega dihalo compound is going to be obtained. And when we perform the distillation under reduced pressure, we're going to cleave the ring and substitute the nitrogen, and we're going to get 1,5-dibromo-pentane, a simple alkane is going to be obtained. So see, this is the second von Braun method to degrade secondary cyclic amines from this alkaloid compound. Reductive degradation process is there as well. The pyridine or piperidine nuclei, if any alkaloid have this nucleus, this skeleton in it, may be estimated as ammonia and normal pentane by heating with hydroiodic acid at 300 degrees centigrade. So if we have these two kind of skeleton in any alkaloid compound, by treating it with hydroiodic acid at 300 degrees centigrade, we're going to remove this nitrogen in the form of ammonia and we'll get normal pentane. So this is another degradative process. Oxidation, through which we can perform the degradation. It gives the information about the fundamental structure of alkaloid, position and nature of some functional group or side chain, as either the carbon-carbon double bond is there or primary alcohol in the form of CHOH etc. This kind of information can be obtained through the oxidation. Oxidation of cocaine to picolinic acid, that is pyridine 2 carboxylic acid, suggests that cocaine is alpha substituted pyridine derivative. So we have cocaine as an alkaloid. On performing oxidation, we're going to get this picolinic acid. That suggests that it is alpha substituted pyridine derivative, and that is how we can get more information of the complex structure of alkaloid. Another oxidation process, by varying the strength of the oxidizing agent, a variety of the product can be obtained. If we use milder oxidizing agents such as hydrogen peroxide or ozone or I2 in ethanolic solution or alkaline K4FeCN6, we can do some mild oxidation process. We can carry out the mild oxidation process to identify the different substituent attached to the heterocyclic ring structure of alkaloid. Similarly, we have moderate oxidizing agents such as acid or alkaline KMNO4 or chromate in acetic acid. We have a vigorous oxidizing agent that already you know that it is K2Cr2O7 dichromate, potassium dichromate and H2SO4 combination, chromate and H2SO4 combination, concentrated HNO3 or MnO2 with H2SO4. These are vigorous oxidizing agent. By knowing this oxidation product, position of double bond can be easily established in the complex structure of alkaloid. Now another is the zinc dust or alkali distillation process. Distillation of alkaloid or its product over hot zinc dust degrade it to a stable aromatic derivative. We have the example out of the 4 alkaloid in our syllabus. We have morphine, and morphine gives phenanthrene ring structure on distillation with zinc dust. It indicates that morphine have phenanthrene nucleus in it, phenanthrene skeleton in it. Similarly, cocaine on distillation with zinc dust gives 2-propyl pyridine, that is cynorine, conirins, conine gives 2-propyl pyridine, that is conirine, and that is also a kind of zinc dust or alkali distillation. Similarly, cinchonine, that is from cinchona bark, we're going to extract this alkaloid, gives quinoline nucleus with alkali distillation process. It means that cinchonine have quinoline nucleus in it, quinoline skeleton in it. Thus this product indicates that morphine and cinchonine has phenanthrene and quinoline nuclei respectively in their structure. This you need to remember as far as the MCQ part of this syllabus is concerned. Alkali fusion of alkaloids with solid potassium hydroxide produce the simple fragments, the nature of which indicates the type of nuclei present in the molecule. If we have adrenaline on fusion with solid potassium hydroxide, gives protocatechuic acid, which indicates that adrenaline has protocatechuic acid nucleus in its structure. So this is the reaction. By performing this, we're going to get this nucleus. Dehydrogenation. Alkaloid is distilled with a catalyst such as sulfur, selenium or palladium to form simple product to find out the gross skeleton of alkaloid. Find what are the heterocyclic ring skeleton is present into the alkaloid, that can be obtained by this catalyst like sulfur, selenium or palladium. That is also a dehydrogenation process. During this dehydrogenation, groups like hydroxyl or C-methyl groups are eliminated from the alkaloid, and type of linkage can be established. Which kind of linkage is there in the complex structure? When we will learn the synthesis of alkaloid, we will learn retrosynthetic analysis of the alkaloid, where we will break the complex structure of alkaloid into simpler fragment, and then by studying the synthesis in a forward way, we're going to establish those two fragments, and then we will try to establish the linkage of those two fragments to form a total synthesis of the alkaloid. There this process can be much helpful. Another physical method that all you people know, that is IR. Various functional groups can be identified using UV visible, that indicates the likely structure of the compound. X-ray will going to give us information regarding the stereochemistry of alkaloid. ORD, optical rotatory dispersion method, is there to establish the structure. Circular dichroism is there as well. NMR can help us to find out the olefinic proton or N-methyl or O-methyl or C-methyl group, or either heterocyclic ring present into the complex structure. And mass spectrometry will help us to find out the type of nucleus, size and side chain of the complex compound. So using this various method, we can establish the complex structure of alkaloid. Last but not least, finally, the structure proposed by degradative method is confirmed by the ambiguous synthesis. That means we need to perform the synthesis to establish the structure finally found by these all different chemical and instrumental tool or methods. This much is enough from my side. Thank you very much for paying attention to this lecture, and I always inspire you to ask question, because you know that asking question is a beautiful way to acquire knowledge. Thank you, Sam. 3 students. This slide is for the correction, where because of the video the pictures distorted, and here are some questions for your self study as an assignment.